Lesson 7 is called Forms of Equations of Lines, and we're going to look at 3 different forms: slope-intercept form, point-slope form, and standard form. And we're also going to look at vertical and horizontal lines. So 7.1 is slope-intercept form. So the formula for slope-intercept form is right here. It's y equals mx plus b. That's definitely a formula that you want to write down and begin to memorize. So in that formula, the m represents the slope or the rate of change. So those are interchangeable, slope or rate of change. And what it means is basically like how quickly is the line or just the scenario in general increasing or decreasing. And then b is going to be our y-intercept or our initial value. The y-intercept is where the line will cross the y-axis. Anything that can be written in the form y equals mx plus b is going to show up as a straight line on a graph. So just as a quick little sketch, straight line on a graph. When I say straight, I just mean like no bends or curves or anything like that. So wherever that line crosses the y-axis, in this case, that crosses the y-axis right here, that's our b value. So if like there's a 1 in the equation where b is, the y-intercept, or it's going to cross the y-axis at 1. So if you haven't already, go ahead and pause and write down the formula as well as the notes below it about slope and y-intercept. And then just a quick thing to review, in general for like really in all functions, I guess. Maybe not all of the changes, but most of the functions that you'll ever see in your life. X is going to represent something called the independent variable, and Y is going to represent something called the dependent variable. And that means that X determines Y. So X is something we put in and it affects our output or our outcome, which is Y. So next section, writing linear equations when given 2 points. So write the equation of the line that goes to the points -3, 2, and 5, -6 in slope-intercept form. So that's our y equals mx plus b form. So step 1 is to find the slope. There's 2 different ways that we can find the slope. I'll use one for this example and a different way for the following example. But the slope formulas, but they end up actually being the same thing. So you really get to pick which one you prefer. The first one is m equals y1 minus y2 over x1 minus x2. You may also see it written the other way around, like y2 minus y1 with x2 minus x1 in the denominator. They mean the same thing because ultimately you get to pick which one is going to be your point 1 and which one's going to be your point 2. The other formula over here with the triangles, so it's m equals, so this triangle is called delta and it represents change. So both those triangles mean change. And so that's just saying like the change in y over the change in x. And again, it'll end up having the same outcome as the slope formula over here. So you ultimately get to decide which one you prefer. Okay, so I'm going to use this one for this example, and then I'll use the other one for the other example. So step 1, find m. So we'll do m equals, and I'm just going to copy that formula down really quick. So it'll be y1 minus y2 over x1 minus x2, and then you get to decide which one is going to be your point 1 and point 2 out of the points that you're given. It really doesn't matter, especially here we have negatives in both, so it doesn't really make a huge impact. Okay, so I will call this my point 1, and this will be my point 2. So for the way that points are organized, the x goes first, so this will be my x1, this will be my y1, so x and y, and then this will be my x2 right here, and then this will be my y2 right there. So I'm just going to go ahead and kind of show where we're going to put each value. So x1 is -3, that's going to go right here, and then y1 is 2, that's going to go right here, and then x2 is 5, that's going to go right here, and then y2 is -6, so that's going to go right there. So we have to be careful because the slope formula has subtraction signs in it, so we may end up with some double negatives. So y1, that was 2, minus, and then y2, which was -6. So y1 is 2, and then minus from the formula, and then -6 for a y2. And then x1 was -3, and then minus x2, which was just a +5, so -5. And then anytime you have a double negative, so minus a negative, it turns into a plus. So 2 minus -6 is going to turn into 2 plus 6, so that's 8. And then down here, -3 minus 5. So I like to think of it, if I were to start at -3 and then I go down 5 more, I'm counting down 5, so I'll just get more negative. So -3 minus 5 would be -8. And then if we can reduce, we want to. So this is now just like 8 divided by -8, which is -1. So our slope, or our rate of change, is -1. Step 2 says substitute m into y equals mx plus b. So we just figured out that m was -1, so we're going to put that in the formula where m goes. So the formula is y equals mx plus b. And then instead of m though, I'm going to take that m out and just put my slope there, which is -1. So you can decide whether or not you want to leave this 1 there. It's technically the same as if you were to just have the negative sign out in front without the 1. I'm going to leave it there for now just to kind of see like where we're plugging things in, but I'll eventually take it out at the end. Okay, so step 3 says choose a point to substitute in for x and y. So the purpose of step 3 is that eventually we need to find what b is. So we found m and we need to find b, and those are the two things that we need to be able to write this equation. So in order to find b, we have to make sure that b is the only unknown. So then we need to put something in for x and y. So you get to pick one out of the 2 points that you're originally given to use. So I'm going to use -3, 2, and it doesn't matter which point you pick, so you can pick whichever one you feel like is easiest for you. And we'll put the x coordinate in for x. So the x coordinate is -3, so we'll put that in there, and then we'll put the y coordinate in for y. So we'll put the 2 in right there. So then that'll be 2 equals -1, and then times x, which is -3, and then plus b. So we put in -3 for x, we put in the 2 for y, and then we need to simplify and isolate b. So we would have to multiply these two together next. So it would be, oops, I'm actually getting ahead. I'm like kind of going into step 4, so I'm going to stop for a second and read through step 4 at least. So moving down to step 4, it says solve the equation for b. So step 3 was just to put in like x and y for x and y from one of our points. Step 4 is to solve for b. So that means to like essentially get it by itself in the equation. So what I'm going to do is I'm just going to copy down my equation from step 3 down here. So 2 equals -1 times -3 plus b. I want to start to isolate b, so that means getting that side of the equation simplified first. So I'm going to multiply -1 and -3 together to get +3, and then plus b. And then I eventually want to get b by itself, so I have to use inverse operations to cancel out the things around b. That 3 is being added to b, a +3, so I'm going to cancel it out by subtracting 3 from both sides. So then 2 minus 3 is -1. -3 times -3, that cancels out, which is what we're trying to do. And then we're going to bring down our b. So we have b equals -1. I promise it's not always that m and b end up being the same thing. It was just in this case. So now step 5, substitute m and b into y equals mx plus b. So it's y equals mx plus b. That's our formula. And then we need to put -1 in for m. So I'm going to take that m out. And we could put a -1 in there, but we usually don't write the 1 if 1 is the coefficient, or -1 for that matter. So instead of that, I'm just going to put -x. We'll just leave the 1 off. And then b was also -1. So if I were to put a -1 right here, that looks kind of funky because it's like plus -1. So anytime b is negative, instead of plus negative, you just write it as minus that number minus b. So y equals -x minus b. That's a line with a slope of -1 and a y-intercept of -1 as well. So when writing an equation through 2 points, you need to find m and b. You can follow these steps anytime you have a problem like this where you're asked to write the equation in slope-intercept form from 2 points. Next section, writing linear equations from real-world situations. So Samantha was curious how fast she reads. She wrote down how long it took to read up to a specific page number in a book. The following table shows the page number she read and the number of minutes that she read. So after 8 minutes, she read 5 pages. After 11 minutes, she read 10 pages. She read 20 pages in 17 minutes, and then she read 25 pages in 20 minutes. So if we want to write a linear equation, we're going to write it in slope-intercept form. So it's y equals mx plus b. So we're pretty much going to follow these same steps, but we're just not going to make a table out of it. So first thing we're going to do is we're going to find m. And I'm going to show finding it the other way this time, which is like thinking of it in terms of like triangle y over triangle x. So we'll say m equals, I'm going to copy this formula up here, down there. So m equals change in y over change in x. And then to find that change, I just need to pull 2 points out of the table. Remember that the table is just a different way of organizing points. The left side is typically x, the right side is typically y. So I'm just going to pull the first 2 points out. So 5, 8. And then the second point is 10, 11. And you don't have to pull necessarily 2 consecutive points. You don't have to pull the first 2. You can really just pick any 2 from the table. And then if I want to find the, I'm going to leave that. If I want to find the change in y, that is like, how do I get from one y to the other? So how do I go from 8 to 11? I'm adding 3. So the change in y would be adding 3. And then for the change in x, how do I get from one x to the other? I'm going from 5 to 10. So to go from 5 to 10, I'm adding 5. So my change in x would be a positive 5. So when you use this method, it doesn't matter which point you start with, but you should start with the same point for x and y. So I'm either starting here and going here, or I'm doing the reverse. I'm starting here and going here, but for both the x and the y coordinates. If you have a table, you can technically do this directly from a table rather than writing it out like this. So you pick, say, those same 2 points that we picked up here. So the change in x, or I'll start with change in y actually. The change in y, so we're looking at the change on the right side of the table because that's the y side. So from 8 to 11 is 3. And then the change in x, we're looking at the left side of the table because that's the x side. I'm going from 5 to 10, which is adding 5. So you get the same thing, like plus 3 for y, plus 5 for x. So you can do it directly from the table as well. Okay, so now we have what the slope or the rate of change is, which is 3/5. So the next step is to take that 3/5 and to put it into y equals mx plus b where m is. So it'll be y equals, instead of m, I'm going to put 3/5 there. And then x plus b. And then next I need to solve for x. So the way that I would, solve for b, excuse me. The way that I would do that is I'd have to pick a point to put in for x and for y. And then that'll leave me with b as our only unknown, so we'll be able to solve for it. So the point that I'm going to use is 5, 8, this point right here, or the first point on the table. So that means that I'm just going to highlight it to show what we're putting in where. So the x coordinate from 5, 8 is 5. So we're going to put that in for x. And then the y coordinate from 5, 8 is 8. So we're going to put that in for y. So we'll put 8 in for y. And then equals 3/5 and then times x. So times 5 and then plus b. So now b is our only unknown, and that means that we can solve for it. Unknown just means like that's our only variable in the equation. Okay, so I'm going to bring down my 8. And then I need to simplify the right side of the equation before I can get b by itself. So simplifying means multiplying m and x essentially. So 3/5 times 5. So because these have the same like number in the numerator and denominator, you can think of it in terms of cross canceling. What that means is you divide a number that's up top and a number that's down below by the same common factor, which these are both divisible by 5. So if I divide them both by 5, this would become a 1 and this would become a 1. So I would just be left with 3 times 1, which is 3. And then the only number left in the denominator at the bottom is a 1. So 3 over 1, I don't have to write that. I just write it as 3. And then I bring down the plus b. And then I want to get b by itself, so I have to cancel out that positive 3 that's being added to it. So I would subtract both sides by 3. So then 8 minus 3, that would be 5. And then 3 minus 3, that would cancel out. And then I would bring down my b, and I end up with b equals 5. So I have to take that b and substitute it into the equation up there, and then that's going to give me my final answer. So altogether, it'll be y equals 3/5 x. And then instead of plus b, b is 5, so I'm going to put a plus 5 there. So y equals 3/5 x plus 5. Okay, moving on to 7.2. 7.2 is something called point slope form. So pause the video, write down the formula with the notes around it. So point slope form is y minus y1 equals m times x minus x1. So in this formula, m is still the slope or the rate of change. The x1 and y1 are going to be from a given point. So whatever extra point you're given, those will go in for x1 and y1. And then eventually you can simplify and get it into slope-intercept form, which is y equals mx plus b. So example 1, Bailey's baking some cookies for a bake sale. She knows that for each batch of cookies she makes, she needs 1.5 cups of flour. For 6 batches of cookies, she uses 17 cups of flour. So write an equation in point-slope form that represents the amount of flour used, and then convert the equation to slope-intercept form. So point-slope form, that is that formula that's up at the top of the video right now. And then slope-intercept form, that's y equals mx plus b. So that's our ultimate goal. Okay, so I'm going to read through the first part of the problem one more time just to underline important information. So Bailey's baking some cookies for a bake sale. She knows that for each batch of cookies she makes, she needs 1.5 cups of flour. And then for 6 batches of cookies, she uses 17 cups of flour. So slope is also known as, like we said, rate of change. So that's how much, like in this case, essentially her like recipe is going to change by depending on how many like cookies she wants to make. So that's that first section that's underlined where it says that she needs 1.5 cups of flour for each batch of cookies that she makes. So for each batch of cookies she makes, she needs 1.5 cups of flour. That's gonna be our M. So like if she needs one batch of cookies, she needs 1.5 cups of flour. If she needs 2 batches of cookies, she needs 3, because 1.5 times 2 is 3, my bad. And then like 3 batches, she would need like 4.5 and so on. And then, so we have M, that's one part of point slope form. The other point is going to be the given point, so like the x1, y1. And to figure out that, we have 2 more numbers, of course, like 6 batches of cookies and 17 cups of flour. We just have to kind of figure out, okay, which one is our x and which one is our y. So to do that, we need to kind of look at what's our independent and dependent variable. So remember that x is the independent variable. So in this case, we have to think about like, okay, is the independent variable, I guess, like how many batches of cookies she's making or how many cups of flour she needs. So if she wants to bake a certain amount of cookies, that's going to be like kind of her deciding factor. So that's going to be her independent variable. So we'll say X is the batches of cookies. I'm just going to shorten it to batches. And then depending on how many batches she needs to make or she wants to make, that's going to determine how many cups of flour she needs to use. So remember that X determines Y. So that means that Y is going to be the cups of flour. So how many cups of flour she needs depends on, is the independent variable. It depends on how many batches of cookies she wants to make. So what that means for our problem is that kind of helps us decide like what is going to be the x1 and what's going to be the y1. So it says that for 6 batches of cookies, she uses 17 cups of flour. We said that x represents the batches of cookies, so that means that x1 is going to be 6 for the 6 batches of cookies, and then y1 is going to be the 17 cups of flour that she uses for those 6 batches of cookies. Okay, so it's kind of a lot, but we have all the information we need now, which is M and then X1 and Y1. So I'm going to start with just copying down the formula. So Y minus Y1 equals M times X minus X1. And then we said M was 1.5. So we're going to put a 1.5 in for M. And then we said X1 was 6. So we're going to put a 6 in for X1. And then we said y1 was 17. So we're going to put a 17 in for y1. So once we put everything in, it'll be y minus 17 equals 1.5 times x minus 6 for x1. So we have our equation in point slope form. So going back to like the final instructions for the problem, it says write an equation in point slope form that represents the amount of flour used. That's this. So that's the first part of the problem. And then it says then convert the equation to slope intercept form. So that's what we're going to do next. So I'm going to label these just so we can kind of see like the differences in our final answers. So this is going to be number 1. And then number 2 will be slope intercept form. Okay, so to convert it to slope intercept form, which again, that's y equals mx plus b. So what slope intercept form is, it has a y by itself on one side of the equal sign, and there's no parentheses, and everything is simplified on the right side. So on the right side of the equal sign right now, I have parentheses. So my first priority is to get rid of those. So I'm going to do y minus 17. I leave that alone for right now. And then now to get rid of the parentheses, I have to distribute that 1.5 by everything inside the parentheses. So I do 1.5 x and then 1.5 times negative 6, which is negative 9. So I've distributed 1.5 times x is 1.5x and 1.5 times 6 is negative 9. So that takes care of like this side is simplified, but now I need to make sure that y is by itself. So that means that I have to isolate y. So I want to cancel out that minus 17. So the opposite of subtracting 17 is adding 17. So that would cancel out the minus 17, but I also have to add it to the other side of the equal sign, and I'm going to line it up under the 9 since those are like terms. So I'll bring down the y, and then negative 17 plus 17 cancels out, and then equals, I bring down my 1.5x, and then I have to add negative 9 plus 17, which is kind of tricky, but it's the same thing as 17 minus 9. You just switch the order, which is positive 8. So altogether, y equals 1.5x plus 8. So that's going to be our like second part of our answer, the equation in slope intercept form. Moving on to 7.3, which is standard form. So the formula for standard form is ax plus by equals c. So example 1, Max is having some friends over, so he decides to buy some candy. Chewy bars cost 75 cents each, and caramel bars cost $1.25 each. If Max spends $11.25 on candy, and we want to write a linear equation in standard form that models the situation. So standard form is typically for situations like this, where you have, I see it a lot in terms of like when you're purchasing items, because it's really easy to set up equations that way in standard form versus slope intercept form. So going back to the problem, it says that, so Max buys some candy and Chewy bars cost 75 cents each. So that means that he's going to take like how many Chewy bars he buys, and he has to figure out how much he spends on Chewy bars, he has to multiply that by 75 cents. And then in addition to that, he's going to buy some caramel bars, which cost $1.25 each. So to figure out how much money he spends on caramel bars, he has to take the amount of caramel bars that he buys, and he has to multiply it by $1.25. You know, if he buys one caramel bar, that's $1.25. If he buys 2, you multiply that by 125 to get 250, and so on. So Chewy bars times 75 cents is going to tell you how much you spend on Chewy bars. Caramel bars times $1.25 will tell you how much you spend on caramel bars. And then we know how much he spends in total, which is $11.75. So that means if we add how much he spends on Chewy bars and how much he spends on caramel bars, in total he spends $11.25. So I know that this setup we just did does not look exactly like standard form, but believe it or not, it's very similar. So instead of writing like CH for Chewy bars and CA for caramel bars, we're just gonna assign them a variable X or Y, and then the A and the B are going to represent how much each candy bar costs, and the C will be the grand total. So I used the Chewy bars was my like kind of first variable. So just to kind of keep it in the same order, I'm going to say X is the number of chewy bars. And then y is going to be the number of caramel bars. And then to set up our equation, we have to take how much we spend on chewy bars and multiply it by the number of chewy bars that we buy. So we spend $1, or not $1, we spend 75 cents per chewy bar. So 75 times 0.75 times x. And then in addition to that, we spend $1.25 for every caramel bar. So $1.25 times every, or for each caramel bar that we buy. So for y. And then in total, he spends $11.25. So equals $11.25. So this is in standard form now. We can see that this is a constant times x. So 0.75 times x plus a constant times y, so that'd be by, and then equals just a constant over here, that's a number with no variables, so equals c. So 0.75x plus 1.25y equals 11.25. And then the next section says now convert the equation from example 1 into slope-intercept form, which again, that's y equals mx plus b. So what I'm going to do is I'm just going to take this equation, I think I'm actually going to move it down here so it's less in the way, and then I'm going to copy it over here as well. So we want to convert that into y equals mx plus b. We spoke about that a little bit on the last example. Converting it into y equals mx plus b means that we have to get y by itself, so it's isolated over here, and then the right side of the equation will be simplified. With the x term coming first. Okay, so my goal here is to get y isolated, so I need to move things away from it. Usually we try to cancel out addition first, so that means I'm going to try to get rid of this 0.75x that's being added to it. So to cancel that out, I'm going to have to subtract 0.75x from both sides. So these will cancel out because I'm subtracting the same number. And then I will bring down the 1.25y. And then over here, it kind of looks like we should subtract 0.75 times 11.25. However, this is 0.75x, so we can't actually combine them because they're not like terms. So in order for it to be in slope-intercept form, what I want to do is I want to write the x term first so that it lines up with having like mx and then plus b, which is just a constant. So I would, instead of 11.25 minus 0.75x, I'm going to do my negative 0.75x first, and then I'm going to add 11.25 since the 11.25 was positive. So really quick, more time. I can't combine these because one has an x and one does not. I want my term with the x to come first, so I wrote the negative 0.75x first, and then after that was the positive 11.25. And then next, if I want to get y isolated, I have to get rid of that 1.25 that's being multiplied by it. So I would divide both sides by 1.25. And actually, you can do it as one big line, but I think it's easy to kind of miss something there. So dividing both sides by 1.25 means dividing each term by 1.25. So I can't just do it to one or the other. So if I divide by 1.25 here, that's going to leave me with just y. And then I need to do negative 0.75 divided by 1.25, so you can grab a calculator for it. So negative 0.75 divided by 1.25 is negative 0.6. So negative 0.6x. And then next we'll do 11.25 divided by 1.25, which you should get 9. So plus 9. So in slope-intercept form, this will be y equals negative 0.6 plus 9. Okay, last section is just a quick note on vertical lines in general. So vertical lines, and horizontal lines, excuse me, they can be a little bit tricky at first, but with a little bit of practice, they're pretty straightforward. So I'm just going to give a quick example. Let's say I wanted to graph... actually, I'm going to draw one on here. See, I changed my mind. Okay, so let's say I draw a vertical line right here. And that's kind of off center. I wanted it to go through the 4. Okay, so I draw a vertical line right there. And then if I wanted to write the equation of this line, so there's a couple ways that you can approach it. One is you can look at where the line crosses the x-axis. Remember that this is the x-axis, and it crosses the x-axis at 4. So that's actually the equation of the line. The line would be x equals 4. So it crosses the x-axis at 4. The equation of the line is x equals 4. The other way that you can think of it is you can point out a few points, or like kind of identify a few points that are on this line. So like, let's say this point right here is 4, 2. This point is 4, 5. This point is 4, -3. So what do all those points have in common? They all have an x value of 4. So the line must be x equals 4. If you had an equation that you had to graph rather than like identify the equation for the line, let's say I wanted to graph x equals -6, I would go to the x-axis, which is right there, and then I would identify where -6 is, and then I would draw a line through -6 on the x-axis. You couldn't draw a line this way though, because it's not just crossing -6 on the x-axis, it's crossing every line on the x-axis, and I want one that just crosses -6. Okay, so if vertical lines are like x equals, then horizontal lines must be the opposite. So horizontal line means it goes side to side. So let's say I have this line right here. If I want to write the equation of the line, I look at what axis it's crossing, which is the vertical axis, which is the y-axis. And then I look at what number it's crossing at. This is, we can't see it, but it's crossing at 3. So that means that the equation of this line is y equals 3. Okay, you can do the same thing on this line as like kind of identifying points that are on the line to write the equation. So like this is the point 2, 3. This is the point 6, 3. This is the point -5, 3. So all of those points have something in common. They all have a y coordinate of 3. So just another way of doing it. And then if you have an equation that you need to graph yourself, so let's say I have the equation y equals -2. Well, I would look at the y-axis and I would find -2 on the y-axis, which is right here, and I would draw a line through it. So it ended up being a horizontal line. And again, you wouldn't draw one this way, because even though it crosses through 2, it crosses through literally every single other number on the y-axis, and we want one that just crosses through 2.